Hello there. Well, now we know why Franck wanted the extra time for lunch, don't we? He was planning a little extra long lunch. Okay. Well, we've given this slide about 2 hours worth of work. I guess we're done with it. Okay, next. There he is. Next slide. Okay. We've talked some about this already, so we can do it quickly. And that is that today we have virtual reality as a mainstream concept in physics. But it wasn't always like that, you know. And when I wrote these books in 2002, published them in 2002, there were only 3 people that I know of who would publicly stand up and say that virtual reality was a necessary good idea. And these are the 3, other than me, that I found in a internet search on the subject. It really, there wasn't much there. Edward Fredkin published 2 papers in science forums. Edward Fredkin is a physicist, and he's a well-known and renowned physicist. I think his professorship, he's a professor, was at MIT and then Boston University and then Carnegie Mellon. So those are all good science houses, good institutions. And he wrote these papers and claimed that reality indeed must be digital. And one of the statements he made in making that claim, which is just very elementary logic, was that if reality is virtual and digital, then it must be computed in, quote, other, unquote. And other meant other than here, other than this virtual reality. And the reason is that a simulation, which is what a virtual reality is, cannot compute itself. You know, trivial logic, right? You know, a camera can't take a picture of itself. You know, a computer or a virtual reality can't compute itself. So the computer had to be an other. And he went on to describe some of what other was about. You know, how many bits it must have and so on, how many bits are here, and this is a subset, then other has to be able to compute things at least as big, if not bigger. So he did a little sizing of other and a few other things, but mostly he didn't talk much about other. That really wasn't too much of his theory, other than it was just a logical consequence of virtual reality, is that it has to be computed in some other reality frame other than the virtual reality that's computed. Trivial piece of logic. What that means to the elf in World of Warcraft is that the World of Warcraft cannot be computed inside of the World of Warcraft reality. Okay, that makes sense, right? You have a virtual reality that seems physical to those in it, but the computer that computes it can't be physical inside that reality. It has to be someplace else because a simulation can't compute itself. All right, that's interesting for several reasons. One is that, and Fredkin did not go here because he didn't understand the consciousness connection, or that consciousness was the computer. But that's real interesting because in a virtual reality, there's really a triangle, but it only has 2 active legs, and one of them is the computer, the virtual reality, and the player. This makes up a complete virtual reality game. Now, if you take away any of the 3, then the other 2 no longer have a point, right? You can have the computer and the player, but no virtual reality, then there's no communication between them. You can have the player and the virtual reality, but if there's no computer, really there's no virtual reality. See, there's nothing, no action could go on, nothing could change. If there is a virtual reality, it's static. And you could have the virtual reality and the computer and no player, and then there'd be no point. Because, well, why would you make a virtual reality that, wasn't of any value? So those three things kind of need each other. The virtual reality itself is just data in a computer. So the only two active things are the computer and the player. And the computer and player have to trade data. A virtual reality game is that the player makes a move, makes a choice of what its virtual character needs to do, sends that choice defining data to the computer. The computer implements that choice, changes the reality a little, moves the character someplace else, then sends that picture back to the player, who then sees that his character has moved as requested. So it's just data going back and forth between the computer and the player, and the virtual reality existing on a hard drive. That's the way virtual reality has to work. Once you say virtual reality, then all that is just a logical consequence of a virtual reality. That means that if the computer has to be an other and is non-physical, so does the player, because the player and the computer have to communicate. You can't communicate directly across a different reality frame. So if you're going to be communicating directly like you need to between a computer and a player, you have to be in the same reality frame. So now consciousness is also non-physical and lives in other. Now consciousness can't live in the virtual reality. I mean, we think we have consciousness, somehow attached to our brain and it's living here in this reality, but that's not the case. Why can't consciousness live in a virtual reality? Because a virtual reality is just information on a hard drive. How does consciousness live in a bunch of ones and zeros on a hard drive? That doesn't support consciousness. Consciousness is something that processes, it does things, it's unique, it has free will. You don't have free will amongst ones and zeros on a hard drive. It doesn't make any sense. Consciousness can't be in the virtual reality any more than a computer can be in the virtual reality. You can think of the virtual reality as a whole bunch of still pictures, if you like, sort of like the movie. Every picture is created by the computer going through another time increment. When you compute a dynamic simulation, you compute the way everything is, all the rocks and the water and the elves and the barbarians and the trees, and everything gets computed. And then the next delta t, you compute it all over again and add the changes. What moved during that time? What in the next delta t is a little different than it was in the last delta t? That makes a dynamic simulation. So every delta t, it's like a still picture, if you will. That's how we make movies. We take a bunch of still pictures and we run them together and it looks like a movie. Well, we take a bunch of these samples in time of this simulation, we run them all together and it looks like a movie, as long as delta t is small. So it works the same way. So consciousness can't be in the hard drive amongst the ones and zeros. Makes no sense. And it has to be in the same reality as the computer. From that, we understand that consciousness is non-physical. It does not inhabit your brain or your body. It has nothing to do with your body any more than you, the game player, sitting there with your computer and your keyboard manipulating your elf. Do you feel like you're in the elf? No. Your elf is just a virtual avatar and you're making all the choices for it. But nobody thinks that they are in the elf's head, in the elf's brain. That's not the way it is. Now with us, consciousness works a little different than it does in the virtual reality with World of Warcraft. Because, one, our reality is not programmed. It's a virtual reality that has been evolved. That's one big difference. I'll talk a little bit more about that later. It's an evolved reality, not a programmed one. And secondly, we, as consciousness, are immersed in this virtual reality. Okay, so I'll run through a little bit about how one ends up being in the virtual reality. So let's say that you have your virtual avatar has died. The rule set says he's worn out, right? It's been a long time. Avatar's worn out. Avatar dies. You are a consciousness, okay? You end up now in a frame that is a virtual reality frame. It's a virtual reality for transitions. In this transition frame, you begin to lose your sense of the virtual experience you just had, very much the way you lose your sense of a dream. In a dream, you wake up and it's clear and it's vivid and it's right there, and about 30 seconds later it's sort of there, and another 30 seconds it's only half there, and within a minute or two, you just remember kind of the big, certain parts of it. It kind of goes away, and by an hour later, you might remember that you had a dream, and it may have been of this kind of dream, but you really forgot all the details. That's the way it is when you wake up after your avatar's died. You have a sense of the virtual reality that you've just been in immediately. You wonder, where the heck am I? What's going on? Then you get engaged in order to distract you. And eventually it just kind of fades, and there you are, and you start to wonder, well, what am I going to do next? And somebody leads you over to where we start planning for the next virtual reality experience, you see. So I made that kind of short. If you're interested in that, we can talk about it later. Okay, now what happens? As that sense of the past virtual reality fades, that partition between the free will awareness unit, okay, that's what we are as chunks of individuated consciousness. I don't know, maybe I'm getting ahead of the game here, but I'll do it anyway because you were most all there yesterday. I may have to do this again, but we're chunks of this individuated consciousness. We're pieces. And we can partition off a part of ourselves, just the being level part, not the intellect, just the being level part. So we partition off a part of our consciousness that just exists at the being level. And then when we decide what avatar it is we're going to play, partition off this being level part, and we say, all right, we're going to play this avatar. And then we do just like you do when you play World of Warcraft. Log in, give it your password, and your username, and then you hit the start button. Same way you start that. And what that start button does, it makes a connection, just like it does in World of Warcraft, between you and the computer, given relative to a given avatar. Now, after that, this subset of the individuated unit of consciousness, we call that a free will awareness unit. This free will awareness unit then is immersed with this data stream. It has no intellectual part, just has a being level part. Now, the being level part carries all the quality of that consciousness, carries all the substance of that consciousness. It just doesn't carry the intellectual part. So now the credentials were put in, the computer starts sending data relative to the avatar picked, and now this subset of consciousness, the free will awareness unit, gets that data. And what does it do with that data? Well, it doesn't know what to do with that data. You see, it has no idea, but it learns because the data it gets is from an avatar fetus, an avatar just being birthed. And as it gets sense data, because even in the womb, the fetus can see the light, can feel the constrictions, can punch mama, can kick and do other things. So there's sensations there. So the avatar begins to interpret these sensations. After birth, it can interpret, the air, it can interpret the bed, it can interpret mom and dad and the teddy bear and the teething toys, and all of this stuff now is new input, and the consciousness learns what these things are, how they relate to each other, what's important and what's not. Eventually it learns words, what to call them. It learns to speak, how to speak. This is all the consciousness learning this, you see. And as this avatar grows, then the consciousness develops with it, making choices all along. It's got the quality of its parent, of its individuated unit of consciousness. And it's got the experience, which is developing its own intellect with this avatar. But it's totally immersed in the experience. See, in World of Warcraft, you can always put the game on pause, go to the refrigerator, make a sandwich, get something to drink, and come back later. But that's not the way it is here. Our consciousness, our free will awareness unit, is immersed in this experience with us, you see. And it doesn't really know anything else other than that first data stream it got, and it has to figure out, what in the heck does all this mean? How do we interpret it? And that's the infant's job, is to figure all that out. So it learns as it goes. And then, of course, it works that avatar until that avatar, by the rule set, runs out of steam, it dies. It's a free will awareness unit, goes to the transition frame where it begins to forget what's going on. And as it forgets, it becomes reunited or reconnected, or if you can say the partition is opened up, and it's part of the individuated unit of consciousness again. And it's that individuated unit of consciousness that begins to bargain and deal and decide what it's going to do next. Okay, so you see I've gone through a whole cycle back around to where we started. So that's a description of how we end up thinking that we are this body, because we've been here from the very first sensations that were interesting enough for us to learn something about what it means. And we're totally immersed in it. We don't leave to go get a sandwich. We are here and stay here all the time. So that's the connection. That's why we have this sense that the consciousness is in our body. You know, it's in our head, it's us. Because we've been making these choices since before birth, since there was something to make choices about. And as we grow up and gain more quality of consciousness, you know, those choices help us evolve or de-evolve. We learn, we grow, we have fear, we have love, we care, you know, we have ego, we struggle, and then we get to do it all again and again, because there's no, you know, it's not like public school, at least where I am. You don't get passed just because you tried and you're old enough. Here, if you don't get it right, if you don't grow up, well, you go back and try again, and it's not a time test. You get as many tries as you like. So that's the nature of the game. That's really where the idea of karma comes from, is that you don't, you know, you don't pass without doing the work. So if you're trying to learn anger management because you tend to get angry and fly off the handle, you will have to deal with that problem until you conquer it. And until you conquer it, you will constantly be dealing with that problem. So there's no, you know, it's not that if I do something to you, you'll do the same thing to me later. You know, karma doesn't work like that. That's too simplistic, and it's not that specific. It's just that you have to keep working on the things that you don't learn. So if you do things that make bad choices, you'll have another opportunity to work at that choice. Not the same identical choice, but a different choice in a different way, but it gets at the same result. Okay, so that's the process that we go through, and that's why we are the way we are. It's why we think we're in here, because we've been here from the beginning of our intellect, and that's why we don't remember. I have lots of people tell me, it's really a ripoff. You know, why can't I remember all the things I learned last time? Well, all the things that you don't remember is just intellectual stuff, and that's not really where the quality is. That's not what's important. That's just baggage. That's stuff you have to unlearn. That's all the stuff that keeps you from going forward. You've got the basic quality from the being level. That's where you start with. Everything you earned up to that point, you got, and you get to keep it. But you got to start back at zero to express it again in choice. And that's the name of the game. That's how we play that. I don't know how that got into Edward Fredkin, but anyway, we'll go on. The other one was Nick Bostrom. He was a philosopher, and I think he had some science background as well. He also thought that doing logic, you know, philosophers do logic, and he started with a blank slate and said, you know, what's the probability? What's the logical probability that this might be a virtual reality? And after studying it for a year or so, the answer was, it almost certainly is a virtual reality. That was what logic told him. And Brian Whitworth compared the two, said, here's virtual reality, and here's regular reality, which is just is. Reality is, don't ask me anything, you know, shut up and calculate, it is. and here's the virtual reality. And then he looked at all the facts we know, all the scientific experiments and what they show that we know, and which one is the better physics at answering, connecting the dots and answering the questions. And by and far, it wasn't even a close comparison. The virtual reality just way outperformed the traditional reality view as far as connecting the dots, which is why virtual reality will become an accepted concept in physics, because it's better physics. Even if you struggle against it, eventually we'll get there. I think there's no choice. It just does better physics. And the better physics will, in the end, win out. As Planck said, maybe one funeral at a time, but it will eventually win out. Okay, now Friedkin, nor Bostrom, nor Whitworth, nor dozens of others at universities who kind of see the fact that we're living in a virtual information-based reality would take the next step and say that consciousness is the computer. I've not heard anybody but myself make that step. But you see, it's just, that's not a new paradigm. That is just deductive logic from the fact of what does a virtual reality mean and how does it have to work. There aren't any other ways or possibilities for virtual reality to work except the computer, the user or the player, and then the computations on a hard drive. That's it. Virtual reality doesn't come in any other flavors. So just deductive logic tells you that consciousness is going to be the computer, because you have a consciousness that is an information system, right? That's what consciousness is. We get information, we interpret it. We give out information, we communicate. Consciousness makes choices. Consciousness is an awareness that gets data, processes the data, makes choices about the data, and then sends that data back to implement the choices. That's consciousness. And what is that? Well, that's information system. It's trading information with a computer. So consciousness is an information system. The computer is an information system, and they both just happen to be in the same reality frame. That's not just luck. They obviously are connected, and then it makes good sense later on when we see why it should be that way. So anyway, right now, though there are lots of physicists who think virtual reality is a good idea, none of them are ready to say that it has anything at all to do with consciousness. In fact, most of them aren't even ready to say that it has to be computed in other. And that's such a simple logical step that, I call that's like third grade logic, that a simulation can't compute itself. That doesn't take a large brain to see that's one of those, tautology. It's just obviously true. So I saw a bunch of physicists on a YouTube panel, and the subject of the panel was virtual reality. And they were there from all over the world, top physicists. Friedkin was among them. And they were discussing virtual reality, and all of them was very pro virtual reality. They were there from MIT, and they were there from Caltech, and they were there from some of the CERN scientists and some of the big powerhouses in Europe. And it was this group of about 7 or 8 physicists. And Friedkin, at one point, brought this up. He says, well, since this is a virtual reality, it will have to be computed in other. And then the camera kind of panned over the other 6 physicists, and they kind of sat there like deer caught in the headlights, and nobody said anything. And it was a long silence. And then one of them said, well, not necessarily, and then changed the subject. So that's where that stands. You see, something that obvious. So it's not a matter that they're not smart enough to see the logic, it's that they just don't want to go there. I think we talked about that this morning. It's not a place that they are comfortable with. So academia is not really a very open-minded place. Academia has a lot of political correctness that is enforced. If you want to succeed in your career in academia, you have to, be part of the club. So that's probably, it's going to be one of the last groups that gets it, or that's willing to admit that they get it. I think the rest of us, people like you and me, will have to drag them kicking and screaming into the future. They're going to want to ignore and deny as long as possible. But eventually, we'll get there. Okay, next. All right, now I'm going to tell you why C is a constant. And then you and I and the other people that have seen these lectures will be the only ones that know. All the rest of the physicists, you'll know more physics than they do, because you'll know why C is a constant and they won't. Okay. Think of this as just pieces of conceptual cells of space. Okay? Now, space is just a computed thing, right? Space comes out of computer, just like in a simulation. If I have a simulation of an airplane flying, that airplane's flying in simulated space. Space is just a coordinate system. It's a 3D coordinate system to find space. That's just mathematics. So that's the kind of space this is. This is just conceptual space, not that there's real space in the consciousness system. Okay? Now, each one of these is a little volume. See, it's a little cube of space, and don't get hung up on the idea that it's a cube and not a sphere or something. This is just a kind of a cartoon to get some concepts across. So here's a little chunk of volume in space, and there's one, and there's one. That's all what the delta V means, a little chunk of volume. The delta means a little piece of, is what delta is. And it's a space-time reality cell. Okay. Now, if you are going to compute a virtual reality, the first thing you need to know is how big a computer do I need? What's the throughput? What's the data? How much data am I going to have to deal with? And how fast am I going to have to deal with that data? Right? Those are the two things that you have to understand before you even begin to build your simulation. How much data? How much throughput? How fast do I have to deal with it? Okay. Well, that boils down to resolution. How small are these delta V's? How little are they? How much resolution do we get? How many pixels do we want in this three-dimensional reality? Now we're talking about these little 3D pixels up here, 4 little 3D pixels in a row. Okay, and the other one is, pixel is a size, so that's how much data, right? You're going to get a piece of data from every pixel. Just like on your TV screen, your pixel has an intensity and a color, and that's it. So you get one of 3 colors, and you get an intensity. So you get 4 pieces of data in every pixel. That's how much data your computer has to deal with when it updates all the pixels. It's 4 pieces of data per pixel. So here we have pixel size, which then relates to resolution. How much resolution do we want in the reality? Well, it's like how much resolution do you want in your photograph? How much resolution on your computer screen? You know what resolution is, and how much resolution do you want in this reality? Well, that depends on what you're going to do here. If you're going to do real fine work, you need more resolution. If you're just going to do general work, then you don't need so much resolution. You get less data. Okay, now, what about the refresh rate? On your computer screen in World of Warcraft, depends on how old your monitor is, but it's probably getting at least 60 updates a second. 60 cycles a second is a refresh rate. Now, the newer ones are 120, and newer ones yet are 240. So that's how fast they refresh the data. How often does the computer update those 4 numbers that define that pixel? The intensity and one of 3, and a mixture of those 3 colors. So those are the key things. Okay. So we have a pixel is a little chunk of volume. We got here 3D pixel. Is a little chunk of volume. That's delta V. This is delta V with a Greek delta, and that's it spelled out for those people who don't speak Greek. This is a frame rate. How fast is the data updated? And every delta T, it gets updated. That's a little chunk of time. Okay, so with a computer monitor that's 60 times a second, then that delta T would be 1/60th of a second. So then 60 times every second does it get updated. So 1/60th of a second would be your delta T for your screen. Or 1 120th a second, depends on how fast your computer operates. All right, now if we look at this and we say, well, now how fast can I move data through this reality? Well, I can go from this cell to that cell, to that cell, to that cell. I have to move through contiguous cells. I can't jump. If I move from, let me get the button here, this cell jumped over to that cell, that's called teleporting. And that's not the way our reality works. Our reality is contiguous. You have to go from cell to cell to cell. You don't teleport around in here. That would make it a strange reality. So how do you do that? Well, if you take a cube root of a volume, you get a distance. And if you divide a distance by delta t, you get a speed, a velocity. Well, you get a speed, okay? And what does that tell you? That tells you that as fast as you can move through here is 1 delta x, if you want. That'll be the delta x. That's the distance, the cube root of the volume. And so you get 1 delta x every delta t. So it's here. Next time the time function goes around, it's here. And the next time it's here. The next time it's here. That's as fast as anything can possibly move through this simulation. Is one of these pixels every time it refreshes the simulation. Well, that is the speed of light. Why is speed of light a constant? And why is it the fastest speed that you can get to move through this reality? Because it's a virtual reality, and that's as fast as the computer can push data from cell to cell through the reality. And it depends on the resolution and the frame rate, just like any other virtual reality. And you got to set that first before you start doing your virtual reality, because that tells you your requirements. Your computer resources you need to run this come out of that. So this is one of those constants that's in the initial conditions of that rule set. We said we had this tight ball of plasma, and that tight ball of plasma has initial conditions. That's one of them. And it has a rule set. And part of the rule set, and I guess another initial condition, is this delta t. How fast do you want to process this thing? What's your refresh rate going to be? Delta t is the refresh rate. So that's why c is a constant. So once you make an assumption that this is a virtual reality, the big mystery of why c is a constant, which is really the fundamental knowledge that you have to have in order to do relativity. Once you understand c is a constant, you can come out with special relativity with a little algebra. It's not even advanced math. You can get special relativity, and then general relativity was built on that to add gravity. But relativity pops out with a little algebra and this one assumption that c is a constant. But nobody has a clue why this c ought to be a constant. It's just one of those, just is, like the rest of the stuff, like mass and charge and so on. So that's why. See, it makes sense. Once you have this idea of a virtual reality, just all kinds of things just fall out and make sense where they were mysteries before. That's what builds some confidence in it. Okay. So again, you see there's more and more credibility for this being a virtual reality. Why? Because a good model is defined by how much things it can explain. How many points does it satisfy? All the data points for all the facts. This model needs to run a line through all of them. It needs to explain them all. Okay. So if, I guess I should say this, the delta V and the delta T need to be constants. The reason they need to be constants, which is what makes C a constant, is that if you had different size pixels, I don't know if you've ever seen a picture on a TV screen with different size pixels, but it's like looking in a funhouse mirror. Everything's distorted and stretched, and it's this way here, and then it moves over to the bigger pixels, and everything stretches out, and you lose resolution. It's not the kind of reality that you'd want to, make a virtual reality act like that. So you need delta V as a constant, or the virtual reality is not good. Delta T has to be a constant, because otherwise your time would be like speeding up, slowing down. The time between ticks and talks of your clock would sometimes be a long time and sometimes be a really short time, and it's like you'd be in slow motion and then you'd be fast forward. And that wouldn't be a very good idea either. So to make a consistent virtual reality that is, and it needs to be consistent because we want feedback. We want to learn from our choices. So we need to know that when we do something, we're going to get the same thing back. We can't have the delta T's and delta V's changing and being variable. They have to be spec'd in order to spec the computer requirements, and then they have to be constant, which makes a constant C. Okay, so see that? That's a physics lesson, and you're smarter now than a lot of physicists. Okay, next slide. It's not my next slide. Oh, yes, it is. I turned 2. All right. So that's relativity. Let's see if I said anything here that I think I've said all that. So the magnitude of C represents a constant that specifies the demands placed upon the virtual reality rendering engine. Okay, so C is specified, evolved to suit the available computational resources within the larger consciousness system and the fidelity requirements of the virtual reality. Okay, so it's enough physics for a while. Let's go do something else for a while. Okay? This makes a point of something we've already talked about, but maybe it'll make it stick a little better. This thing is not a potato, and it's not a cloud. It's a consciousness, sort of. It's a cartoon consciousness. And this is consciousness 1, and it has information 1, and it has experience 1. This is consciousness 2, and it has information 2 and experience 2. Well, the point that needs to be made here is that the only way for these to communicate is with data. Passes data back and forth. And this is a fact of our being in a virtual reality and passing data as we do, that let's say this consciousness 1, it has an idea, okay? It has an experience and it wants to share. It has to get that idea and it has to put it into data. Now that data for us may be our language, maybe a picture. It has to put it into some sort of data. And then when it puts it in data, that data can move from here to here. The experience can't move from there to there. See, the experience is something inside consciousness, non-physical consciousness. You can't send the experience. You have to send a description of the experience. So this is your description of the experience put in data. That symbolizes that. And you send it over here to this other consciousness who interprets it like that, because it has to interpret it based on its experience. You see? So you send out something that probably isn't exactly like your experience, because you really can't put your experience precisely in data. All you can do is describe it. So here's the first approximation right here, trying to describe your experience in terms of this data. You can sort of describe it, using some metaphors and other things, but it's very incomplete and it's not perfect at all. Then you send it over here to this consciousness, and they take that imperfect thing and interpret it with their own data. That's why it's so difficult to communicate with anyone. Now, if both of these people are from, both of these consciousnesses live in the same culture and use the same metaphors and have the same perspective on life, then they can do this with less error. But if one of them gets plucked out of the jungles of the Amazon and the other one is a Wall Street banker and they're trying to communicate, they probably don't have a clue what each other's saying or where each other's coming from, because their metaphors are different. The way they interpret things are different. What's important to them is different. Everything is different. So this may come out like that, and it may show up over here as a square. That's the way it is. Or another example, if this is a guy and that's a girl, it's the same problem. That star shows up as a square, you see, because men and women interpret data and process data differently. We interpret the world in a different way. We see things differently. So there's a communication problem that just is a fact, because we're transferring data. It's an information system. We're transferring data. We can't transfer experience. We can't transfer a feeling. We can't transfer anything. We each are in our own reality, and all we can transfer, I shouldn't say transfer anything, we can't transfer anything directly. All we can transfer is data, descriptions based on our own experience. How much fear we have, how much we know, how ignorant we are, all those things determine how we do that. That's why 5 people standing on a street corner see the same accident, you get 5 different reports of that accident. They all look like, each of them saw a different accident because each one of them interprets the data differently. Okay, so reality must be a first-hand experience, a first-hand experience to the consciousness. It's subjective. See, that's the point here. Reality is subjective. It's personal. It's not out there. There's no objective reality out there. There's just a virtual reality, and we all have our own view of it, and we all see it in our own way. So reality has to be a first-hand experience. There is no objective reality. You have all of this stuff, fear, belief, expectations, understanding, feedback, all those things modify what you have. So this is the all experience subjective. Okay. The appearance of objectivity is nothing more than a commonality of viewpoint. That's why the things that have very little uncertainty are the ones we most agree on. And the things with very little uncertainty are the things that we call objective. They're not really objective, but they're approximately objective. Okay, next slide. Okay, consciousness and reality. Consciousness is the fundamental reality. The larger consciousness system is a digital information system. At the most fundamental level, consciousness is information. Your senses collect information, your consciousness interprets it. Your senses don't actually collect information. That's the way we do it in the virtual reality, like the elf. The elf's senses collect information, right? The elf looks over here and his eyes see the lake, and he looks over here and his eyes see the mountains. So we pretend that the elf has sensors, can see, can hear, can smell. Our elf has these things, but he doesn't really. That's just part of the rule set. That's the way the rule set says that this avatar works. You see? So it's not really that we even have the senses. It's just the rule set says that when I look here, I see the window, I look here, I see the wall, and it appears as if we are sensor platforms getting in the data, but then that's virtual. It's virtual data, virtual sensor platform. It's not really sensing. All that's going on is computers talking to a player, and the rule set says what's in that data stream. Okay, so consciousness is information. Information is bits, and bits are binary. So we've worked it down to the most basic level. Information is non-physical, subjective. Thus, consciousness is non-physical and subjective. Information is non-physical. Data can be physical. Information is the meaning. Information is the content. Information is the message. Information is not the media, like your computer screen or paper in a book or a CD, plastic with ones and zeros in it. That's the media. And it's not the code symbols. It's not the words, not the ink on the page. It's not the little divots that make a difference between a 1 and a 0 on your CD disc. Okay? It's the information. And to convert that data into meaningful, significant information requires a consciousness. If there's no consciousness, it's just data. Okay? So as long as those ones and zeros stay on that CD, it's just data. As soon as that data gets displayed or gets sent to the avatar, and the avatar with his virtual senses senses it, because that's the way the rule set says this virtual reality works, then that consciousness can interpret that data. But without the consciousness, there is no information. Okay, so understanding requires a subjective interpretation of the data relative to unique personal experience. Okay, we're going to talk a little bit more about these things later. Next slide. Okay, now we're going to talk about information systems and evolution. Okay, so we know an information system is a digital system. That's the most general form of an information system, is a digital system. It's the most flexible and the most basic form. And it's represented by organized bits. Okay. Information systems have entropy. Entropy is a measure of disorder. High entropy is high disorder. Low entropy is low disorder, which means structure. Planning, what can we say? Symbols that connect to each other that mean something. That then is lower entropy. Randomness in an information system is no data. Anything that's random has no information in it. That's the very definition of random, is that it contains no information. Okay, so if all the bits in a system are random, that system has no information. If some of those bits are ordered, then it has some information. There's some kind of structure to it that has meaning, has significance. Okay, so how does an information system grow or evolve? It does that by lowering its entropy. Lowering entropy is how an information system maintains itself, evolves. Otherwise, if it raises its entropy, more and more of its bits go random, eventually it disappears and there's no more information. The system is gone. So we're talking about a consciousness as an information system, so we see that consciousness must be in a process of evolution, must be in a process of lowering its entropy. Otherwise, it would disintegrate. Okay. I think we've said all that. Okay. Now, information systems lower their entropy, and consciousness systems make choices. So what we do as consciousness systems that are information systems, we have to make choices in order to lower our entropy. That's how we work. So that means we have to make choices that create more structure, less randomness in our cells and in our environment. That's what we do. So if we think of this information system, I guess I'll go a little bit to the origins. I think I've got that on another slide here, but we'll do it now. Seems like a good place to do it. We'll talk about the origins of this consciousness system. How does a consciousness system come to exist? Okay, well, it's a very similar logical process as to how does our biological world come to exist. In biology, we start with an assumption, two assumptions. One, the first cell. Two, evolution exists. You get a cell and you get evolution, and those two can create all of this. You've probably seen that in school. So it gets complex, and that's just the logic of evolution. And of course, we can dig out artifacts and bones out of the ground and other things that kind of tell us how that process went. But those are the two things you need: a first cell, because otherwise evolution doesn't have anything to work on if it starts with a zero. So there's an assumption. Where did that first cell come from? We don't know, but we need to have it, and here we are, so it must have been there somehow. Besides that, we can kind of guess that maybe some inorganic chemicals just happened to be in the right place at the right time. A little bit of electricity from a lightning strike got them energized, and they made an amino acid, or they made a protein, or they made something then that connected with some other amino acid or protein, and they begin to form a system. And that system begins to cooperate and make something that's sustainable. All right, that's just chance that happens. Okay. So that's biology. Consciousness is the same way. So if we call evolutionary biology scientific, then I think we have to call this consciousness evolution scientific, because it's the same plan. Conscious evolution needs a consciousness cell. And what is a consciousness cell? A consciousness cell is a very dim piece of consciousness. Maybe we wouldn't even call it consciousness yet. It's just a primordial awareness that can tell that it has an ability to differentiate between two states of its being. It can be this way or that way. Just two different states. And it knows that. It says, oh, now I feel I'm this way, now I feel I'm that way. It's two different things. I can sense the difference, and I can be this way or I can be that way. That's all you need. If you've got that, your second assumption is evolution. It can take that and start multiplying those this ways and that ways, just like it took that cell and started multiplying how those connections were made. And pretty soon you have a consciousness system that has lots of this ways and that ways, and each this way is a 0 and each that way is a 1, and now you have an information system. Information system has memory, okay, it has a process because we gave it process. It could tell it was this way or that way, so it has a dim awareness. So there's awareness for processing, there's memory, there's input. How else would it know it was this way or that way? It's getting input someplace, how it is, the state that it's in. So it's got all those characteristics of an information system. Now it just has to grow up and evolve. And eventually it grows up and evolves into this. So those are the two assumptions. Consciousness exists, evolution exists. The rest of it's logic. Same with biology. Almost the same with cosmology. Cosmology starts with two assumptions. One of them, that evolution exists. The other one is that tight little ball of plasma that was there somehow before the Big Bang went bang exists. Okay, that ball of plasma exists, and then bang, you've got evolution, and then you have this. That's cosmology, another branch of physics. So you see, they're all starting about the same way, right? They got two assumptions. Evolution is one of them, and the other one is one that is, you really can't verify. You just say that it's like that. So we see all of these theories, and cosmology is a branch of physics. So if you think cosmology is a science and biology is a science, and there's no reason to toss out this concept with consciousness. It's following the same suit. And as we said before, the reason that they all just seem to start with something that just appeared to be there is that's the nature of a virtual reality. Virtual reality just starts with something that appears to be there. That's your mark. Is this a virtual reality? Well, I don't know. Let's see if it just starts with something out of nothing. And if it does, that's a real good choice, a real good probability that this is a virtual reality, because that's the way it has to work. There's nothing until the run button's hit, and then it starts computing. So you go from nothing to something. So that's the idea of where consciousness comes from. And just like biology can wave its hands and say, well, they have these inorganic, compounds, and they get together in a little light, and, they kind of wave their hands and make a little plausibility argument, even though it's not it's certainly no proof. It's an evidence maybe that something like that could have happened, but we do the same thing, and that is we talk about two things, and one of them is emergent complexity. Emergent complexity is a new mathematics that has shown that if you take chaos and you give it enough time, if this chaos has enough, enough of the right stuff, has enough potential, the chaos couldn't just be all ones, randomly scattered, because there's not enough potential in that to generate much. But if you take a chaos that has enough potential in it to become something, eventually it will. Might take a long time, maybe 1 in a billion, that it would happen to go together in the right way to produce something that was stable, but eventually there's a good probability that will happen. Okay, emergent complexity, it's a mathematical theory. And then we have cellular automata that says if you could just get this little process going, which is what you get from emergent complexity, produces a little process, and then cellular automata takes this little process and starts operating on it. Okay, we operate everything that exists on this process, and then that changes everything. And then we take that change and put it back in the process, and that changes it again and put it back. We just keep going through there, and we know that cellular automata can make amazing things. Back to the term of process fractal. Cellular automatas are process fractals. Fractals can take little tiny simple things and make worlds out of them, make universes out of them. You've probably seen pictures of the fractal, and you see a picture of something in synapse inside somebody's body and a picture of something in outer space and something in a plant, and you see, well, they all kind of look like it's the same picture, I mean, there's little differences, but you see all these, and that's because of the fractal nature of our reality. Well, this is a process fractal. You see things that are repeated. You see that we are part of a consciousness system that's a virtual reality, and now we create computers. And after we created computers, we started creating virtual realities. And if our computers get good enough, the elves inside of World of Warcraft will be able to build computers to create virtual realities. See, not really that the elf is doing it. The elf is just an avatar. But the consciousness playing the elf, well, can compute virtual realities inside of that game, you see. So you see how that's the nature of fractals. They repeat. You can see the same sort of patterns everywhere you look. Look at evolution. Evolution is a process fractal. Evolution changes things. Okay, it's mutation, changes things. Then it takes whatever it changed, changes it again. Then that goes back to the input. And look what evolution has done with its process fractal. It's taken that cell, created this whole universe and us in it. That's a lot of creation for a fractal. But indeed, cellular automata have been shown to be able to produce these kinds of things. Some of the cellular automata, very simple rules, have produced unending complexity. Some of them have shown to have all the necessary requirements to operate as a general purpose computer. Well, what else do we need for consciousness? So you see, we can start with that emergent complexity, just by chance get something that is stable, maybe a little rule set. The rule set can be very small, just has to be stable. And then we can let that rule set become a process, and a process builds everything else. So it's the same story that biology has. And how does it do that? Again, it's the same story that biology has, because this is a process fractal, and it's not just magic or good luck that we happen to have the same process as biology. It's because that's the way the reality's built. So you see it in biology just like you'll see it in consciousness. It's the same sort of process being worked again, and you'll see the same process almost everywhere you look. Look at evolution. Cultures evolve. Governments evolve, monetary systems evolve, technology evolves. Everything goes under the same kind of processes. There's rule systems and how they evolve. They change again. They're stable. They keep feeding themselves. It's the way it works. You do one step, you learn something, and that enables you to do a lot more. So it builds on itself. Well, how did biology lower its entropy? Because even though we talk about biology, we say, well, there's two criteria, and that is survivability and procreation. Those are the two criteria for evolution. But if you look at those two, they can reduce to lowering the entropy of the system. Notice how every time biology evolves to the next step, it's more complex, it's more structure, it's lower entropy. Because all those things that are more survivable and better at procreating are things that are more complex, because these complex things have more flexibility. They're adaptable. They have more adaptability because of their complexity, you see. So we really have the same story going on in biology. We're trying to lower our entropy in biological systems. And we're doing the same thing in consciousness. Well, what did biology do? Well, they had this one cell, right? What did the one cell do? Well, there's only certain things that one cell can do. It's very limited into what it can do. How can it lower its entropy? How can it become more survivable and procreate more efficiently? Well, about the only thing it could really do was split. So now there's two cells, and they can interact. Now they can work together. Before, couldn't work together. They got two now working at the same problems, you see. And then they split those, and then you got 4, and then you've got, and so on it goes. So we every time we split, it gets bigger. And then what happens? We have these multi-celled things. Well, what can they do? How can they lower their entropy? Well, they start specializing their cells. Now they have special cells that eat, special cells that digest, special cells that move, special cells that run, whatever. They have specialized special cells that are sensors that see. So they have changed what they were to be specialists in a certain area, because this new organism now is more flexible than ever, because it can eat all kinds of things, because it's got these cells that just specialize in digesting stuff, and they're good at it. So they can digest all sorts of things, very survivable, good for procreation. So you see, it's still entropy reduction. And over on the conscious side, same thing. You have this consciousness, this conscious thing, okay, it's developed lots of ones and zeros and lots of patterns and patterns and patterns and this and that. So it's humming along with its evolution, but it's just this one thing. And it's thinking, how can I reduce entropy here? What can happen? Now, when I say how can I, it's not thinking that. It's just stuff happens, and what happens, it works, goes on, and what happens, it doesn't work, doesn't. I'm making it sound like it was an intellectual choice. That's just making the language easier for us to communicate. But anyway, so what does it do? Same thing the biology did, same pattern. It breaks in parts, so the parts can interact. But now this is consciousness, not cells. So how does consciousness interact? It interacts by communication. That's what consciousness does. It makes choices, and it trades data. That's consciousness. Makes choices, trades data. Takes in data, makes choices about how it's going to process it, sends data back out. That's what consciousness does. So it breaks into pieces. These pieces interact. Now you've got a social system. You have a whole bunch of chunks of consciousness, all with free will, and you have to have free will. If you didn't have free will, there would be no choices. If there's no choices, there is no evolution. If there is no evolution, there's nothing. You don't even have the this way, that way choice that the original cell had. So for any of that to exist, you need free will. Free will and consciousness are logically needed for each other. You can't have one without the other. Consciousness without a free will doesn't work. Free will without a conscious doesn't make any sense. Free will do what? If there's no awareness behind it. So those two go together as a set. So now we have these things with free will, and they interact. And now, of course, the same question comes up. How do we lower our entropy? All right, now we got all these things interacting. What do we do to lower our entropy? And it was obvious that the quality of the interaction, the quality of the choices was key, because some choices lead to more cooperation and structure and lower entropy, and some choices lead to less. Well, what kind of choices are which? The two opposites I'm going to give you as examples are fear and love. Those are opposites. So you have the choices of love are choices of cooperation, choices of caring, choices about other. I'm interested in other. I'm interested in the system. I'm interested in the whole. I'm not just interested in me. It doesn't mean that I can't have any interest in me at all. It's just that I'm primarily interested that we all work together and cooperate, because we can do so much more with that. So that lowers entropy. And that just is obvious, right? That's going to lower entropy. Cooperation can build and construct and make something more. And on the other hand, you have fear. And what does fear do? Well, there's no trust in fear. There's little caring about anybody but self in fear. It's all about me, and everybody is trying to maximize their own thing. Look out for number one. That's the motto in Fearland. And that creates tearing things apart. Everybody's out for themselves. Everybody's trying to take whatever other people have. So if we think about that, what kind of reality do we live in? We live in Fearland, don't we? Because that's the way it works. Everybody's out for themselves. Everybody's trying to take as much as they can get, and then they're trying to figure out a way to keep it. And we group up into organizations to help mutual protection organizations. All right, let's all get together, and nobody will take anything from us, because if they do, we'll all gang together and, defend our territory. Well, you just defined a country, right? You just defined a group. And now these groups can fight with each other, and we call that war. If somebody comes up with a bright idea, I thought of something that's more efficient. It'll really lower entropy. Instead of saying, well, let's give that to everybody so we can all use it and lower entropy, it's mine. If you want some of this, here's what I want for it, you see. That's something that has value, and we sell value. We don't give it away. And somebody else says, that guy's got something of value. I'm bigger than he is. Let's take it away from him. Then I can sell that value. Well, if he can get away with it, then why not do it? You see, so it's not about other at all. You don't mind doing anything else to other. You can bash other if it's to your advantage because it's all about you. So those are the two differences. That's fear land and that's love land. Obviously, one of them is much better at decreasing entropy than the other. One's an entropy creator, the other's an entropy reducer. So then that gets us to the point of why we're here. We are these little individuated units of consciousness. What's our job? Our job is to interact with each other in this virtual reality so that we lower entropy. What does that mean? It means we grow up and become love. So that's our job. We got a mission here. That's what we do. And we just cycle around, do it, keep doing it, keep getting better at it. Why do we have to cycle around through many lifetimes? Because it's something too hard to do in a short time. And the rule set doesn't give us a long time at a chance, one chance, 70, 80 years or whatever, however it is now. It's pretty short as far as growing up and becoming love. And all learning has to be cumulative. You just don't learn something that if there's step A, B, C, and D, you just don't jump in and do D. You got to do A, which enables you to do B, which enables you to do. You have to accumulate your learning. It's a process that grows on itself. So you can't very easily just learn it in one shot if it's complicated. Maybe you can if it's real simple, but if it's hard to do, you're going to have to learn it in progression of efforts. Cumulative, progressive, iterative. That's why we go around these cycles, because it takes a lot of experience packets, as I call them, rather than lifetimes. It takes a lot of these experience packets before you make good progress. So that's the job. That's why we're here. So let's see, what have I missed? Why do we need the virtual reality? Okay, what's the point of the virtual reality? Why do we need it? Well, imagine yourself, you and 10,000, 100,000 other people in a chat room. No rules. We just communicate. Anybody can talk to anybody. Anybody can say anything to anybody. Doesn't have to be the truth. Just say it if it amuses you. So where's the growth there? Where's the traction? Where's the feedback? Okay, I'm going to make a choice. I'm going to say this to those people. Well, what's the feedback? How does that work? They may or may not tell me what any reaction is. They may make up a reaction that was totally different than the one they had to feedback to me, just because that's what they feel like doing. You see, there's just no growth traction. There's no feedback. It's very hard to grow. So what do we need? More rules. We need to find a virtual reality with a more rigorous rule set. A rule set so that when we interact with each other, there's immediate feedback. So when I say something to you, I come up and I say something really rude to you, I get a reaction and I can see it. I know the effect that it's had. Okay? So then you do something rude back and you can get an immediate reaction. So here we are giving each other feedback on the quality of each other's consciousness. And it'll probably end pretty badly, you see. And hopefully we'll learn something from it, that's not the best way to go about interacting with people, which pushes us more to caring about other, thinking about other, and just about self, you see. So the feedback is what gives us traction here on our decision making. Okay, I have overworked this slide. Let's go to the next one. Okay, attributes of consciousness look a whole lot like the attributes of life. Okay, we've already talked about moving toward lower entropy, that love is the is the nature of a low entropy consciousness, which I always like to point out. I get a lot of joy in pointing out that this is a technical definition in terms of physics terms like entropy of love. What is love? Does anybody have a definition for love? And the answer is always no. There's no definition for love. It's undefinable thing. Well, there it is. Love is the nature of a low entropy consciousness. So I like that. Now, the attributes of consciousness are input, is experience. You have to have data. For us, that's our senses. For us as consciousness in other, right? For us as non-physical consciousness playing as avatar, it's the data we get from the computer. That's the input. Well, we interpret that as sense data from our avatar, just like we interpreted the sense data from our elf. We see what he sees. We hear what he hears. Okay? So that's the input. Call that experience. Memory. If you don't have any memory, every input's the first, and you can't get any traction with that either. There's nothing to build on without memory. Processing. When you take in the data, you need to make a choice. Well, how do you make a choice? You got to do some processing. You got to consider some things. If I do this, that. If I do that, this, and so on. So that's processing. And then there's purpose, which is what tells you how to do the processing. I have this purpose. So how do I process this data so that I maximize and optimize my purpose? So those are the things you need. And of course, it's self-modifying, self-improving. That goes around and around the loop. You know, you have the purpose informs the processing informs the memory re-looks at the input or changes the way it deals with the input, and that's what growth is. And it's interesting that those are the identical attributes of the biological cells. That's what biological cells do. If you look at a modern view of a biological cell, they talk about input, memory, processing, function, purpose, and they have a goal. They have a job to do. And they describe cells exactly the same way. What else sounds like that? Input, memory, processing, self-modifying. Sounds like a computer, doesn't it? That's the way I describe my desktop computer, except for that purpose and self-modifying. Those are just a little different. But they can do that. Lots of computers do some self-modification. These days, you throw in your flash drive, and it right away recognizes it's a flash drive, sends you a message and asks you, do you want to open the files on it or do you want to play it? It gives you these things. So it's thinking ahead. It says, oh, I know what this is. I know what my user wants. Here are your choices. You see, it modifies itself in some way. Now, that's called expert. It's an expert system. It's not necessarily intelligence. It's just an expert system. But that's self-modifying, and it can also self-improve. A lot of times, as you go, your program can learn how you work. A lot of the voice programs are like that. The more you talk to that computer and it takes your voice commands, the better it gets at interpreting your voice. So you have to teach it. Well, see, our computers are sort of like that, but they don't have enough of that to be called conscious, obviously, because they don't have free will. They do what they're told, and they don't have a finite decision space. Free will requires, I have choices. I have the free will to choose this or this. Okay? And decision space is something I haven't talked about, but every consciousness has a certain decision space. And that's true whether that consciousness is a bumblebee or a dog or a person. The consciousness, your decision space of a consciousness is all the decisions that consciousness knows about, all the decisions that they can reach. So I have a decision to make. I have a choice coming up, and I see there's 10 things that I might do for this choice. I can only pick one of them. Okay, that's my decision space. Now, there may be another 10 things that I could do, but I'm not aware of them. I'm kind of narrow-minded, and I don't see that other stuff over there that I could do. Well, that's not in my decision space. The only thing in my decision space is these 10 choices that I see that I can do. Now, my decision space could be bigger if I didn't have such a narrow mind that I could open it up and see all those other decisions. But I have this narrow mind, so these are my decisions. So that's what decision space is. A dog has a certain size decision space, things that it can decide to do or not do, and a free will to go with it. So does a bumblebee, just smaller decision spaces. A bumblebee doesn't have that many decisions to make. A lot of its decisions are hardwired. It does them just because it does them. That's the way its hardwiring goes. But there are some that it probably can decide how it's going to make choices. And we, being the humans, we have lots of decision space. We have the potential for a whole lot of decision space. And the more you grow up and become love, the bigger your decision space gets. The more decisions you have, you live in a larger reality. The size of your decision space is the size of your reality. So you grow up, you keep living in a bigger and bigger reality. Eventually, when you get to where you live in all of this reality, you can multi-process into other realities. And then you can live in multiple reality frames all the time. Just live there. So you're not just here, you're here and you're here and there all the time. So you're kind of a permanent resident of both. And you have a bigger decision space. And with a bigger decision space comes, of course, a bigger responsibility, because now you have more choices. You have to be a little wiser how you make those choices. So, all right, that's how that works. And we see this connection between the consciousness and the biology. Seems to be a pretty tight connection. And again, that's because of the fractal nature of this. All right, next slide. So I think we've talked about most of this. There's two assumptions, that consciousness exists and that evolution exists. I think we've been through all of that, emergent complexity. Yeah, the bottom line is rule set created by emergent complexity, which initiated a self-sustaining information system with a purpose, and the purpose is reducing entropy. You see, so the consciousness system, as it evolved, had its own purpose, just like biology was trying to reduce its entropy within a biological environment. Conscious trying to reduce its entropy within an information environment. Same sort of thing. Okay, next slide. We've been through this too. I got ahead of myself. This basically this slide was to start with the idea that we're this and that and grow up through evolution. I think we can, there's the last one that's good that I should have. In the very last bullet here, it says, so where did that initial potential come from, right? Remember I said it came from mathematical theory, that we could get something that was stable from emergent complexity, and that little stable process could then turn out to be a process fractal, like a cellular automata, and that was the kind of the hand-waving argument that made it seem possible. Okay, well, one can say though, all right, given that you had that little consciousness cell, that maybe that'd work that way. But I'm getting the sign back here. The sign is everybody put their hands together and clap with their fingers. Now, the sign is to take a break. We ready for a break? Is that what you're telling me, Frank? Oh, you're having a technical difficulty? All right, so there is one other point to make here. Since we didn't really say where that first potential conscious cell came from, we just kind of wave our hands about how it might have come about, just like biology does. It wasn't really a very good description. There's one other point in the next slide that I'd like to make, and that is, you not only don't know everything, but you can't know everything. You don't know how upsetting that was for my son when he found that out. Yeah, when my son was 17 when he read these books for the first time, and that was the one thing that just bummed him out of the whole thing. He says, not only did I find out in this book that I don't know everything, but I can't know everything, and he was counting on that. That's about right for 17. Anyway, we look at this example, and there's two ways to look at it. I've got this example running in two things. One is, let's look at the This is our universe. This little red spot is our universe. Okay, this little, I should have that here. Yeah, that's us in our universe. Okay, that's our physical matter reality, that little red spot. This thing is what I call in the books our system. That's a little piece of the non-physical that interacts with our physical. There are non-physical things that are interacting with our physical, like the computer, okay? Like the consciousness and the data going back and forth. All this is non-physical, but it's interacting with this virtual reality. The virtual reality being our physical universe. So this is the part of the non-physical that interacts with our virtual reality. And this, then, is like the larger consciousness system, okay? That contains all of that. Now, what's this out here? This is beyond the larger consciousness system. And to understand a reality frame, you have to experience it from within. I mean, you can experience it from within, but to see it objectively, you have to get out. So you have an inside experience, outside experience. If you want to know where it came from and you want to look at its origins, how did it come to be there? You have to look at it from outside, not from inside, because if you're part of it and inside, well, you're there because it's there. You see, you're a part of it. But how did it come to be there is something you have to see from outside of the system. So you need to get outside of the larger consciousness system in order to look and see, watch that larger consciousness system and find out how it existed. How did it come to be? Well, I'm giving a little example here. Let's say that this little spot is a bacterium in our small intestine. And this little spot is our GI tract, right? That's small and large intestines. And that this system is our body. That's our whole body, okay? Now, what would be this system then? Well, that would be all of our environment, right? That'd be our virtual reality outside of our body. Okay, but let's take the perspective of this bacterium. This bacterium in there, what could it possibly know about the body? What could it possibly know about the GI tract? Well, maybe something. I mean, maybe some of those little bacteria could run up and down the GI tract, like Paul Revere and, give messages, that tell the news of what's going on up in the alimentary canal, those fight, what is it, a fight in the alimentary canal. Anyway, so you might know some of that, but it certainly doesn't know much of the body. What does that intestinal bacteria know about, your ears? Nothing. There's no interaction there. It can't know anything about your ears or your nose or your toenails or lots of your, other parts of your body. All it knows is that GI tract. And what could it possibly know about horses and cows and farms and sunshine and rain, nuclear fusion in the sun, the water cycle, ecology? I mean, all of that stuff is critical to what that bacterium experiences. That bacterium has a job. It breaks down food. And as far as it knows, that food is manna from heaven. It just magically comes out of the chute. And you get it and you decompose it. Because that's what they do. That's their job. They're decomposers, and they break down that food, and more manna from heaven pours out of the magical chute. You see, that's the way they see life. But they don't see farms. They don't see sunshine. They don't understand, the water cycle. They don't know anything about the environment at all. And could they? How could they possibly? Let's say that there's a bacterium there with an IQ at 200, made a perfect score on the IQ test. These brilliant bacteria. What can he know of farms and refrigerators and the light bulbs inside refrigerators that help people put that manna from heaven, down that pipe? Nothing. You see, he just can't. It's beyond his ability because he can't get out of there to see it. If he could somehow get out of there and out of this one and get out to here where he could look back at it, he could look back and see the body. And he could say, oh, that's where I came from. All right, I can watch and I can see these bodies. He may even watch a body being born or something, you see. He could see beginnings, but only if he got out here in the world. Well, he wouldn't exist out there in the world. He only can exist inside our GI tract because that's what he does, and that's his environment, and that's where he needs, that's the only place he can stay. So that's the point. We're just like that. You see, we don't know exactly where that first cell came from, nor do the biologists know where their first cell came from. But that doesn't mean that the science is incomplete, and it doesn't mean that there's an infinite regression in not knowing. Okay? What it means is we just don't know. Worse, we can't know because we're stuck in this larger consciousness system. And until we can get out of that so we can stand out here and look back at it and see how it did come about, we can't tell. So that's philosophy, I guess, but it's a philosophy about knowledge. There are limits to knowledge. We have this idea that we can know anything, given enough time. The human beings, we'll find out everything there is to find out. Well, that's true, but only within this system, only within that little red dot. That's the only things we're going to find out. Now, as consciousness, that was as humans. That's all of our experience in the virtual reality. As consciousness, we can get out here and travel around, and we can watch that human process go. We can see that from the outside and understand it. That's what we do when we get out in the larger consciousness system. We can look back at the virtual reality and see how that got started and why it's there and how it works. That's why we're talking about all that. See, we can figure that out. But we can't figure out what's outside of that larger consciousness system. We just can't get there. So it's an impossibility, logically impossible. So you have to just say there's some things you can't know. Well, that's where you have to be out here someplace to tell for sure where that first cell came from, because it's a function that happened out here. Again, it didn't compute itself. You see, it came from, you have to go to other, you have to get outside of it to look back at it. So that's the thing about the first cell. That yes, we can show how it probably might have worked with cellular automata, but we'll never know for sure because we're stuck being inside consciousness. So those are the things you just have to say. Where did that larger conscious system come from? I don't know. Well, it evolved, but where did the thing it evolved from come from? You just don't know. What's outside of it? You see, I'll tell you that the larger conscious system is finite. It's not infinite. Can't be infinite. Nothing real can be infinite. Infinity is just is an abstract, conceptualization. Nothing real can be infinite. It can be big. It can be so big you think it's infinite. It seems like it's infinite. Well, that's not hard to achieve. You can sit in an inner tube in the middle of the Atlantic Ocean and it looks like that ocean is infinite because you're so small and it's so big, but it isn't infinite. It's just big. Well, this larger conscious system is like that. It's not infinite. It's just big. It has to have boundaries because it's real. It can't be infinite. Well, if it's real, it has boundaries. There's this boundary. What's outside of the larger consciousness system? See, you don't know. Now, in my books, I do some conjecture because you can do all kinds of conjecture, but you'll notice that I only do it with humor because it's not conjecture that you should take too seriously. It's just conjecture. There's all sorts of things you can say. You can say, well, this is just one cell. This larger conscious system is one cell in a larger consciousness thing, you see? And maybe the way it works is that when this has gone as far as it can go, and we upload all the data and hit the reset button. Who knows? You see, when you make stuff up like this, you got to make it up with humor and with a little bit of a smile on your face because you're just making stuff up. See, so I'm sure all of us could make 2 or 3 things up about how that would work, but none of it can get past the humor stage because it's impossible really to know that. So it's not a failure of the theory to not be able to specify what was that beginning consciousness cell, where did it come from? Those are things we can't know. That's where the learning to live with uncertainty comes. You just have to accept that we are limited because of where and what we are. And that it's not a matter of, well, I'm sure we'll figure that out someday. Sure, that intestinal bacteria will find out about nuclear fusion in the sun someday. But Not likely. You know, it's not what it does. All right. The next slide. This is another interesting thing, and we're going to revisit those two assumptions. To describe a supersystem, we're going to talk about supersystems and subsystems. You know what this is? A supersystem is where the subsystem comes from. So you have this system, and the system has a piece of itself called a subsystem. It's sub to that system, so it's just a part of the larger system. Well, from the subsystem's viewpoint, that system from which it came is called the supersystem. So you have a supersystem and the subsystem. So the system sees the subsystem as sub to it, and the subsystem sees the system as super to it, right? Have I confused you? That's like that who's on first thing. Anyway, the assumption one is potential energy form, and call it primordial consciousness, exists, a medium capable of self-modification and self-awareness. It's a potential for consciousness. Okay, if we have we've been there and done that. If you have a subsystem, the subsystem cannot logically describe the supersystem because it doesn't have enough information. It's only a subsystem. It's only part of it. So it's impossible for a subsystem to describe the supersystem. Again, another impossibility, because you're taking something that's only a piece and trying to describe the whole with the piece. That won't work. Okay. Now, a supersystem can describe that subsystem completely because it's just a piece of itself. So when you're making an assumption, if we're trying to look at the big picture, then we need at least one assumption, mandated by logic. We need at least one assumption that goes beyond where we're stuck. One assumption has to reach beyond the conscious system. And that's this assumption that consciousness exists. You see, that comes from outside. You can't tell that from outside. If we didn't have one assumption that was mystical, that was outside of our knowing, it couldn't possibly be right, because there wouldn't be anything then that would tie us to the supersystem. We'd just be talking about stuff in a subsystem, and that can't logically describe the supersystem. So when we decide we're going to talk about the supersystem, the bigger system from which we're derived, from which our larger consciousness system there was derived, then it requires that at least one of our assumptions has to be from that supersystem perspective, and that's consciousness exists. So you see, it's a logical requirement that we have that one, and I would call it a mystical assumption, because it's an assumption of something that we can't verify. Okay? No other way to solve it. So if I didn't have at least one assumption that was unverifiable, I wouldn't be able to be describing the bigger system. So that's not really a problem. So we go to the next slide. So that's just a summary of where we are right now. Consciousness is best modeled as a superset, a self-modifying digital information system capable of computing virtual realities. Okay, number one. The larger consciousness system evolves by lowering the entropy of the system. It lowers the entropy of the system by organizing the bits at its disposal into more profitable configurations. Content creation and reorganization opportunities are generated by using conscious intent to apply free will choice to incoming experience data. And feedback of the results of previous choices allow us to modify future choices. That's us. Okay, and then that's just a cycle. The bottom one keeps feeding the top one, and it goes around and around. So that's kind of the summary. That's where we are, and that's kind of consciousness in a thumbnail. All right, go take your break, and when we come back, we're going to do the fun stuff. We're going to do the experiential exercises and talk about meditation and do some healing and remote viewing. So go take a break.